So after my GPS speedometer video, quite some people ask me how the hell do I wire this? Especially how to wire these 3-digit 8-segment displays. I will explain the wiring step by step today using an Arduino Nano. You can use every microcontroller there is that supports the Arduino IDE. I just use this because it's the cheapest one. Also, I will be using a different GPS. It doesn't really matter which GPS you use. Most of them work the same way and use the NEMA sentence format. If you use a different GPS, you might want to search the baud rate of the GPS. It's pretty easy. Just look at the chip, look at the name, search it, and you will see on the datasheet baud rate and then probably something between 4,800 or 9,600. Alright, let's get started. First up, let's take a look at the display. To understand it, let's just take a look at one digit first. We have 8 LEDs representing the 8 segments in this display. We have a common port. Here in this case it's a common anode, so the plus port of all the LEDs are combined. And we have individual pins for each and every LED. So we connect the 5V plus up here and connect the individual I/O pins down here. Of course, if we would directly connect 5V, these LEDs would die. You can look up the maximum rated current these LEDs can handle in the datasheet. Usually it's around 20 milliamperes. You can also look up the forward voltage over these LEDs in the datasheet. In my case, they are red LEDs and have a forward voltage of 1.8 volts. With that we can calculate the resistance we need so that we won't destroy the LEDs. We have 5 volts, 1.8 volts drop over the LEDs. We have 3.2 volts dropping over the resistance. Volts divided by current will give us the resistance we need, 160 ohms. So how can we show a number on this 8-segment display now? Let's say we want to show the number 1. Obviously we have to turn 2 segments on, but how can we achieve that? Essentially we have control over the voltages we have down here. If we have 5 volts up here and turn the I/O pin to on, which corresponds on the Arduino's case to 5 volts, we have 0 voltage difference here, so no current will flow. If we turn it off, we have 5 volts and 0 volts here, so obviously there will be a current running through this LED, essentially lighting it up. So if we want to turn the segment off, we turn the I/O pin to on, and if we want to turn it on, we turn the I/O pin to 0 volts off. If we want to show the number 1, we turn B and C. These are the 2 right segments here, off, respectively on, and we will show the number. But how can we now display 3 digits? We can't really use this concept and multiply by 3 because we don't have the necessary pins. These would be 32 pins only for the segment display. But there is a clever trick which is used here. We have the datasheet of this little segment display. We have these 8 LEDs of each segment, but they are connected. The individual pins down here are connected, and we have 3 different common anode pins. But well, what does it help? If we repeat the same thing, so we show here a number, but we have only one of these pins to 5 volts, only one number will light up. If you have 2 of them, 2 numbers will light up with the same number showing. So if we want 3 different numbers, we can turn on the first one, show the first one, turn it off, do that for the second one, and so for the third one. But I mean, well, we want to see all numbers at the same time, you might ask yourself now. But This is very easy because if we switch really fast between these numbers, our eyes kind of trick ourselves so we see three numbers at the same time. This is persistence of vision. If something very bright hits your eye, you kind of see the after image and this turns then into a continuous image. All right, let's wire this up. We need 8 resistors to connect all these single pins, and we'll connect them to the digital pins 2, 3, 4, 5, and so on. I don't need the point here, the comma points, so I will only connect 7 digits. I've chosen the 220 ohm resistors because I have still many left of them, and we will be a bit on the safe side with the current, so we definitely won't damage the LEDs. To know which pin is which, you can take a look at the data sheet. It says here the pin on the bottom left is pin 1, and then you just count 1, 2, 3, 4, 5, 6, 7, 8, counterclockwise around. Here we have the pinouts, 1, 2, 3, 4, 5, and so on. And here we have the common anode pins. So I will first connect these and then connect the rest. Alright, we've all connected. All that's left is to program the Arduino Nano. Let's do that now. Alright, we are here in the Arduino IDE. So I know I've written the code a bit complex just to reduce the amount of code there is, but it might be a bit confusing for some of you that are not too familiar with the Arduino coding, so C++. I will still try to explain it so everyone can understand. Here we have 2 arrays holding the pins, which the 3 anode pins we have, and the 7 cathode pins. I've sorted them here so it's A, B, C, D, E, F, G. If you use this code, it's very important that you sort them correctly. And if you have the problem that some of the digits are swapped, you will have to swap these numbers here to so the number is correctly represented. Also, I have this digit pointer. This will be later on important. We have 3 of them, and each of them will point to the digit we want to represent on anode 1, 2, 3. For example, this pointer could point to this array segment. This array here stores our information how the numbers are represented. So we have 10 different digits. We have element 0, 1, 2, 3, and so on. And this 0 here holds the configuration which represents a 0 on this display. So we turn on A, B, C, D, E, F, and turn off the G element. For 1, it's these 2 elements, P and C, and so on and so on. So the digit pointer could then point to 0, which holds the information how to represent 0. If I go on in the code, we have 2 timers here. One timer will hold track on when to swap anode, so that we can flash these numbers really fast. And another timer here is just so we can count up. I have a count variable. I have a variable for the current anode, which is connected, so we know which one is connected, so we can turn on the next. This here is irrelevant at the moment, and here we are in the setup function. We just for loop through both of these arrays to configure every pin to output, every cathode pin and every anode pin to output, and turn them off respectively on. Alright, let's take a look at this function, display number. It has a parameter, an integer, a number, and it will then configure these digits pointers, these 3 digit pointers, to point to the correct digits. For example, if we give this function the number 172, so 172. We want the digit 0 to be 2, the digit 1 to be 7, and the digit 2 to be 1. How can we do this? This is where the modulo operator helps us. Modulo is division, but the result is the remainder of this division. So if we use the number and modulo 10, we get the remainder, which is obviously 2. If we divide the number by 10, important fact here is the integer division will just round down this number. So we divide by 10, we still have 17. We modulo 10, we get 7, and so on. So the digit 0 pointer goes to the segment of 2 pointer. Exactly what we want. So if we just use digit 0, we then get the segment 2. Here we have the show digit function. This function should show one digit with the specified anode, so either digit 1, 2, or 3. It will turn off the other 2 anodes, then write the digital pins with the respective digits, and then turn on this respective anode to show the number. These are both helper functions, and now we are in the loop. The upper part here is responsible for flashing this anode. So every 1 millisecond this code will be executed. So in this function, the current anode is swapped to the next one. So if it's 0, it goes to 1. If it's 1, it goes to 2. And if it's 3, we have 3 modulo 3, which is 0 again. Then it will show the digit at this current anode and reset the timer. So essentially everything it does, it sets the current anode to 0, 1, 2, 0, every 1 millisecond. This code bit up here is everything that is needed in the loop. Down here, I just used a bit of code so we can demonstrate the display. Every 0.1 second, this will increase the count by 1 and then display the count so that we see it. And then reset the timer so it does that again. So it just counts from 0 to 999. Let's see what that looks like. And now with that program uploaded, you see the counter counts from 0 all the way to 999. All that's left is to connect the GPS and actually use the data from the GPS to display the speed onto this dial here. And thankfully connecting the GPS is a very easy task compared to the display. We have 4 pins, a supply voltage pin, a receive pin, a transmit pin, and a ground pin. Both of the GPS devices that I use are 5 volt tolerant. Be careful, not all of them are. Make sure that your GPS that you are using is 5 volt tolerant. You will destroy it if you connect it to the Arduino otherwise. Connecting the GPS is simple. We just connect ground to ground, 5 volt to 5 volt, and then we will use 2 pins to form a software serial connection. So we can use any 2 pins. I will use the analog 0 and analog 1 pins. Alright, now let's write a code to incorporate the GPS and the segment display. Alright, we are back in our code. Now the first thing to do is we will include a library. The way you do this is you go to Sketch, Include Library, and then Manage Libraries. And I will be using the tiny GPS library. Now that we have installed this library, we will include it up here in our code. The way we do this is with include and then the library name, which is tinygps.h. Also, we will be using the software serial library to connect to the GPS. Then we will create our tiny GPS object here and our software serial object. which we call SS. Here you have to put in your RX and TX pins, which you connect to the GPS. I will be using A0 and A1. The first one is the receive pin and the second one is the transmit pin. So transmit pin A1 goes to the receive pin of the GPS and the receive pin A0 goes to the transmit pin of the GPS. I will also create a variable that is called GPS baud rate, which in my case is 9600. This is just the speed at which the GPS and the Arduino will communicate. Also depends on the GPS you use. Alright, in the setup function, we will now also have to initialize the software serial. This is simply done by ss.begin. And then we have to declare the baud rate, which is the GPS baud rate. Now in the loop, we will have to check for the data that we get from the GPS. So we say while if we have something available at the software serial, we will pass it on to the tiny GPS library. The way we do this is we say if GPS encode and then say ss.read. The if function just returns true if there's a valid character being parsed. So we say we have new data. This part up here we have to keep because we still want to update the display, but this part down here we can delete because we want to now actually show the speed. But we will keep the timer and use it to update every second because our GPS runs at 1 Hertz. Then we ask ourselves if we have new data, or better said, if we don't have new data, we count up. And if we don't have new data for 3 full seconds, we will show this on the display so that we know that something doesn't work. If we have new data, we say count 0 because we have new data, and we will display the number. Alright, the GPS.fspeed gives us the speed that the GPS has, that the GPS measured, and we'll convert that into an integer. This is not really necessary because it will be converted anyways. If you want to have miles per hour, you can also use miles per hour. Then at the end, we have to reset our timer. Say timer 2 is equal to current millis. Alright, and with that the code's done. And let's see how that looks once it's uploaded to the Arduino. And with the final bit of code, the project is done. Now keep in mind, if you start a GPS from cold, which means that you haven't started it in a while, it will need time to find the location of satellites, so you have a bit of a warm-up time. Then again, it will find some satellites first, and as time goes on, it will find more satellites and the speed and position will get more accurate. I'm in a building here, I've just started it up, so you can expect a bit of a noise coming through. You see it shows 1 kilometers per hour too, which obviously at the moment is not completely true. And with that, everybody, thanks for watching and see you in the next one.